One strategy to do that is, for example, that second one. Let me copy it back to the side. This is untrimmed, so I like the trimming option with it, like the boundary of it. I like it, but I don't like that it's not evenly spaced. Paneling tools will provide multiple options or multiple routines to work with surfaces. One of them is the domain length. That will actually attempt to create a bit more even distances. So select my surface. You give it some default U length and V length, and you'll see what happened here. Despite that it's more dense towards the edges, the parameterization of that surface, it actually, starting from that base point, it actually had a more even kind of distribution. I can change the distances afterwards to what I want. Whatever left over your surface is gonna like generate a smaller bay of grids. And this will start to look maybe more, suitable to what you needed it to look like. So if I try to panel that, and then you'll see how that is becoming quite a bit more even than the first way that we followed. So depending on your need, you need to kind of choose the routine that is more suitable for you. So whether domain number, domain length, that's really kind of useful options. Now if I work with my trimmed surface and I wanted a more even, again, distribution of my grid, then using the surface domain length is not really going to help me much, because I still have that angle. It's I still have that trim. I still have my grid going with an angle, although it's a bit more evenly distributed. But that's not the direction, for example, that I want to work with. I want it to be orthogonal, like following the X and Y directions. So that's not going to be good enough for me. Instead, I can create the grid using what is called the projection. The last two routines, which using one direction curve or two direction curve, and basically array them in one direction and the other, and calculate the intersections and what have you. It's very suitable routine for trimmed surfaces or surfaces that you want to impose certain directionality when you create your grids, or poly surfaces. Actually, that's really great option to use for poly surfaces. Now, let me just quickly show you how that works. So you select your base surface or poly surface, and then you can select a curve to be your base, or you can generate a line on the fly. Let me just select the edge of that surface. Now what you can see that, well, my base now is flipped to the right, because this is where the direction of that curve is going, so that's the beginning of it. And what it did is basically it copied or arrayed that line in the direction that is the green arrow direction, which is, if you go to curve options, it gives you the option of how many cuts, how many number of cuts you want to generate. Let's say 15 of them. How many, some of them are going up now, but if I change the spacing to 2.5, that's probably the kind of spacing that I'm looking for. And I can change the extrusion direction and the projection direction to be suitable to my need. Now I change these options, I can change the grid options. That means in the red arrow direction, what is going to be the spacing in that direction that I'm looking for. So I can divide it by length or by number, and I change the number of spans to make it denser or not. And then you can enter to accept your options, and that's maybe the kind of a grid you're looking for. Remember, that's a trimmed surface that has its own kind of diagonal parameterization, and now we ended up creating a grid that is more uniform and in the direction that we are looking for, and then we can apply our panels to give it the kind of look we are looking for. So this is really a huge point that is usually very painful for people trying to work with base geometry that is presented to them, and they don't know how to control the direction of their patterns. I hope that's going to help you with with your work working or generating panels, and that's really conclude the second part of our presentation, which is understanding the guiding geometry and its effect on the generated grids. If we have any questions at this point, I'm happy to go over. Otherwise, we can move to the next section.
There were two questions, Raja. One of the questions was, is there a quick way to update your paneling tools? And this is probably a feature suggestion. So up under the paneling tools menu, the request was for a check for updates.
Check for updates. Okay. I guess the way to do it at the moment is to just check your version number, September 4, and if you are not sure this is the latest, you just go ahead and go to the link where it shows you the link to the download, and you can compare the release date here that gets updated, and you can download and update. There is no automatic update at this moment, but this is one of the things that the Rhino plugin installer is going to implement in the future, and you will probably start getting automatic notifications for an update for paneling tools.
Okay, and the other question was, can you apply these grids to surfaces and polysurfaces equally? And I think you're moving into that answer in the next section.
That's right. And the fact that we just mentioned this, I mean, that's the surfaces. It was how we created this one. If you had a surface here, I'll quickly gonna copy this. And so if you had a poly surface, let me join those. And obviously, I mean, you're going to get into a freeform situation, but it's not very different than what we're doing right now. The principle is the same. Now I'll just create a line here to use for my base. But you'll see what we've just done in the previous step applies really here. So you can create your grid using directional curve projection, and you use your base surface or poly surface. So I'm choosing this one is a poly surface. It has two faces. I'm selecting my line, and you'll see that it's now distributed on top of the so number of spans. Let's increase the density to 30, and you'll see how that didn't really care about the seam in between, and it's really going to go across the poly surface. So if I come to generate the panels, now I'm getting a continuous kind of look. Let me just drag these panels to the side so you see how they are actually not disrupted by the seam. So no matter what the shape of the seam is, you use that projection method to work with poly surfaces. So hopefully that quickly answers that question, and we're going to elaborate in the next section, as Mary said. So why don't we just move to the next one now.